Okay, example 4 involves a convex spherical mirror, and we have to draw a ray diagram and then compute the mathematics of it to figure out what the position, size, and orientation of the image is. So let's start off with part A, and part A says to draw a ray diagram. So since there's no setup drawn in here, the first thing I would do is draw the principal axis, which is basically a long parallel line, something like this. So take your ruler, draw a long parallel line right across your page. Next step is somewhere in the middle of this, you can label here the vertex of your mirror. And then the radius of the curvature is given as 22 centimeters. I'm going to use a scale of what we're going to say that basically 2 centimeters is equivalent to 1 centimeter. So we're going to scale this down here. And so that right around here, 11 centimeters away on my screen here, this is point C, which is the center of curvature. And then halfway between that will be our focal point, which is 5.5 centimeters, which is actually, in reality, it is half of 22, which is 11 centimeters. So the next thing we want to do is draw in this convex mirror in here, and if you have a compass with you, go ahead and use that and put your picky point here and draw a nice arc of a circle in here. If you don't, then just do it roughly. And remember, you should be using your ruler when you do the ray diagram. So here I've lightly dashed an arc of a circle, and so I'm just going to darken here the edge of the mirror along here and then along here. So now I'm ready to place my object roughly 16.5 centimeters to the left, which is, again, for my scale, is going to be only 8.25 centimeters. Right about here is where I'm going to put my object. And so here's my object. Now, my object says it should be only 0.6 centimeters tall, but I've obviously drawn this a lot bigger than that. And the reason I'm just doing that is that if I used 0.6 centimeters, I will end up with a very tiny image, and I just want it to see nice and large. So I'm going to use, obviously, a different scale for this object here. And you can indicate here and say the scale here is 3 centimeters is equivalent to 0.6 centimeters in my case. Okay, so now let's go ahead and start drawing our ray diagram. Our first ray is the ray that is drawn from the top of that arrow towards the mirror parallel to the principal axis. And it's going to reflect away from this focus. So here we go. Here's our outgoing ray. And our outgoing ray is coming over here, and really you'll see that it seems to be, it's coming, you should have that outgoing ray basically in line with this focus. And you can do this right away right now. You'll see why in a minute. If you draw this dotted line right for that parallel ray. And the reason for that is that we'll find that the image is going to be behind the mirror. And so when your eye looks at this ray coming through here, the rays in the end are not going to intersect from this diverging mirror. And so your eye will be tricked in thinking that the image is somewhere behind the mirror. So let's go ahead and do ray 2, which is going towards the focus and then going to go parallel off the mirror. So ray 2 is from the top of the object and going towards this focus. So I've lined up my ruler from here all the way right up to this focus here. And then it's going to leave the mirror, reflect off the mirror so that it's parallel to the principal axis. And you can see again these two rays are diverging, and so they will never intersect, and so you'll have to dash back the reflected part here and these will appear to intersect over on the back side of the mirror. So let's move on to getting the center curvature ray. And that's from the top of the object going towards the center of curvature here. So here we go. And then when it gets to the mirror, it will reflect back onto itself like such. And once again, we'll dash this ray back towards the center of curvature here. And you should get it all three of these dashed lines lining up. And there's one more we can draw, which is the ray that comes from the top of the object towards the vertex. And so here we go. We'll start from the top of the object towards that vertex. And it's going to be going from that vertex, obeying the law of reflection. And once again, if you're looking at the reflected beam, your eye is going to be thinking it's coming from behind the mirror, right about here. And so now we can draw our image in here. And you can see the image right here is smaller. It is virtual because it's formed by these dotted rays, and it's upright. So let's go on to, this is part A, let's go on to part B, which is calculating the position, size, and orientation. So we'll start off with the image distance plus the object distance plus equals 1 over the focal length. And the object distance was placed at 16.5 centimeters. And the focal point, or the focal length, if you recall, is half the radius of curvature. And the radius of curvature is given as 22 centimeters. But be careful here, since this is a convex mirror, the focal point, or focal length, and the radius of curvature are both negative because they fall behind the mirror. So you should be putting in negative 11 centimeters here for the focal length. And you'll get an image distance of negative 6.6 centimeters. So that's what this distance in here is. SI is negative 6.6 centimeters here. And the focal length F was negative 11 centimeters. And this distance here, SO, is 16.5 centimeters. So now let's go ahead and calculate the magnification. Negative SI over SO. That's negative 6.6 centimeters divided by 16.5 centimeters. And that will give you a magnification of positive 0.4. So what does this all tell you? Well, the negative 6.6 centimeters tells you that the image is 6.6 centimeters behind the mirror. Therefore, the image is virtual because it's behind the mirror. Secondly, the magnification, since we have a positive magnification, that tells us that the image is upright. And since we have a magnification that it has an absolute value less than 1, then it is smaller. And that is consistent with our ray diagram. And that's it for this example.